this video, I'm going to discuss how to find an x value, where x is some normally distributed random variable, when provided with probabilities. Okay, so for example, find the 95th percentile of this distribution. Okay, so this is a distribution of x, and x has a mean of, it could be anything, so say 10, sigma is, 2. Okay, so here in the center is 10, and I'm asked to find the 95th percentile, which means, with this cutoff, what is this value of x for which 95% of the population is less than that value of x? Okay, so, say I'm supposed to find this. Well, how am I going to do this, right? Well, I know how to find, if I have the distribution of z, right? So say this is the distribution of z, right? And here's 0.95. I know how to find the 95th percentile of z. Now, we talked about that a few videos back, right? How do you find this corresponding z value that where the probability of being less than that z value is 0.95? Well, to do that, you go into your table. So let's go ahead and do it. Let's pull up my table. All right, look for 0.95 inside the table, where the area is 0.95. Okay, and it's directly between two possible z values. So it's directly between 0.9495 and 0.9505. So I'm going to take the z value that's directly between 1.64 and 1.65. So that'd be 1.645. That's going to be directly between. Okay, so 1.645. So this value of z is 1.645. All right. Okay, well, but right now I'm trying to find the 95th percentile of this distribution over here, this x. What is this value of x? Well, it turns out there's a way that we can go from this value of z to that value of x relatively easily. And it has to do with that equation I gave in the previous video, z equals x minus mu divided by sigma. Okay, so I can use this relationship given a value of z to solve x. All right, I'm going to use algebra to rearrange this equation to solve it for x. So I'm going to multiply both sides by sigma. Okay, trying to solve it for x. So I'll have x minus mu. I'm going to add mu to both sides. Okay, so I'm going to add mu. All right, there we go. All right, so now I have an equation where you give me a value of z, mu, and sigma, and I'll give you a value of x. All right, so let's use this equation in this scenario. So x is going to equal, so let's see, the value of z is 1.645. The value of sigma is 2. The value of mu is 10. All right, so x, let's pull out our calculator. Let's clear it out. So 1.645 times 2 plus 10 equals 13.29. Right? So 13.29, right? And it makes sense. That's a number that's more than 10, right? It makes sense that 95% of the population would be less than this number, 13.29. So there we go. That's the 90th percentile for this distribution. Okay, so let's do some more examples where we're using this equation. So now we're going to be using this equation as opposed to before we were using that equation. All right. So to qualify for a police academy, candidates must score in the top 10%. Okay, they must score in the top 10% on a general abilities test. The test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify. Okay, so let's start by drawing the distribution of x, right? So test scores are normally distributed. So x right now is test scores, right? So the test score. So here we go. This is the distribution of x. And here in the center, mu for this distribution is 200. And sigma for this distribution is 20. Okay, so here in the center is 200. And we're trying to find where the cutoff for the top 10 percentile is, right? Where the cutoff is, that'll be the lowest possible score that you can get and still pass and still qualify. So here's 0.1 of the population, top 10%, 0.1, and we're looking for what is this value of x, all right? What is this cutoff here? Okay, what is this value of x? All right, so to find that, we're going to first find the top 10 percentile of the z distribution. So here's 0.1, so this is the distribution of z. I'm going to first find the top 10 percentile of the z distribution. Then I'm going to use my equation that x equals z times sigma plus mu. I'm going to use this equation to get back to what this value of x is. All right, so let's see. 0.1. Now, if I look up in the table, I need to find the area behind this value of z, right? Table gives me the area behind z, this area here. So I can't look up 0.1. Rather, what should I look up? I should look up 0.9, right? This area back here is 0.9, right? 1 minus 0.1, right? The entire area under the curve is 1. So 1 minus this 0.1 is 0.9. So I should look up 0.9 in the table. Okay, so let's go ahead and do that. Let's look for 0.9. All right, 0.9. There it is. It's between these two values, right? But it's closer to this one, right? It's 0.0003 away from this value. And it's 0.0015 away from this value. So I'm going to go ahead and choose this value, which is closer. So 1.28. 1.28. That's the value of z. 1.28. Okay, so now once I have that, I can use this equation here. So x is going to equal 1.28 times sigma. Sigma is 20 plus mu, which is 200. So go ahead and pull out your calculator for that. Go ahead and clear it out. 1.28 times 20 plus 200. 200. Okay, 225.6. 225.6. You should always check that that makes sense. Okay, yep, that's more than the mean, so that does make sense. So 225.6, that's what you need to qualify for this test. All right, let's do one more example. So the heights of a particular type of tree are normally distributed with a mean of 50 feet and a standard deviation of 5. Okay, so I have this distribution here. So x now is going to be the height of the tree, right? That's what we're talking about. So height of tree. Okay, and this is the distribution over here of x. All right, and let's see. So the heights of the tree are normally distributed with a mean. So mu equals 50 and standard deviation of 5. All right, so here in the center is 50. Find the interval which separates the middle 95%. All right, so here in the middle is 0.95. And I'm looking for both this x value and that x value. All right, so let's see. These are going to be two different values, though. That's important. And when we're going to the z distribution, they'll be the same value, just one will be negative. But these will actually be two completely different numbers because it's not centered on 0, it's centered on 50. Okay, so I'm going to mark that as x1 and x2. All right, so over here, my distribution of z, 95% in the middle. So this is distribution of z, centered on 0. This z value will be the same as that z value, except this one will be negative, right? And that's because it's symmetric and because it's centered on 0, okay? All right, so it doesn't matter which one of these z values I find, they're the same number, just that one's negative, okay? So let's see. I need to know what the area behind one of these z values is, so that way I can look it up in my table. It's easier to find the area behind this z value, okay? I mean, I could find the area behind that z value just as easily, actually, but then I'd have to add this area plus that area. So I might as well just find this area and then look up this area that I'm marking here in yellow. All right, so the total area under the curve is 1. The area that's already accounted for is 95%. So the area that's left in the tails must be 5%. Now, half of the area must be in both tails, right? Because it's metric, so half the area is here, half the area is there. So half of 5% is there, half of 5% is there. So if you take 0.05 and divide that by 2, you get 0.025. Okay, so that's the area that's here and there. All right, so let me go ahead and write that. This area is 0.025. This area is 0.025. Okay, so let's look up in the table where 0.025 is. What's the corresponding value of Z? 0.025. 0.025. All right, let's see. There it is. There it is. All right, I didn't scroll up. All right, so 0.025, negative 1.96. Negative 1.96, great. So the value of Z, go ahead and erase this. So the value of this negative Z is negative 1.96. And the value of the positive Z is positive 1.96. All right, so I'm going to use each of these to find these guys. So the one that's to the left corresponds to x1. The one that's to the right corresponds to x2. So let's do that. We're going to have to do this twice. So x1 is going to be negative 1.96 times, let me write down my equation so that we remember it. Remember, the equation I'm using right now is x equals z sigma plus mu. Okay, that's the equation I'm using right now. Okay, so that's z times sigma, which is 5, okay, plus mu, which is 50. Okay, so that's the value of x1. Now the value of x2 will then be positive 1.96, right? That's coming from this z over here. So 1.96 is positive times 5 plus 50. Okay, let's get our calculator. Let's calculate this. So 1.96 times 5. Okay, that is 9.8. Okay, so that'll be for both these guys. Let me go ahead and write that. x1 then is negative 9.8 plus 50, which is the same thing as 50 minus 9.8, right? This one will be 9.8 plus 50. Okay, all right, let's calculate that. So let me go ahead and clear. So 50 minus 9.8, 40.2. Okay, and then 50 plus 9.8, that's easy. That's 98. 9.8. So this will be 59.8, and this one will be 40.2. Okay, so your interval is between 40.2 to 59.8. Right, so 95% of the trees, their heights, 95% of the tree heights are between 40.2 and 59.8. Right, always double check that makes sense. Look at your graph. Yes, it does make sense that it would be, some number that's less than the mean and then some number that is more than the mean. Okay, so 95% of the tree heights are between 40.2 feet and 59.8 feet.